This is the Unit 7 study guide answer key for questions 8 through 13. For these questions, you're going to want to have a periodic table handy. I've got one that I'm going to scroll to here at the bottom of the video, but probably these numbers are going to be way too small for you to see on the screen, but I will be using this to point out how I'm answering these questions. You also have a periodic table in the back of your planner, and they're super easy to search and find a lot of different types on Google. So back up to the top. For question number 8, if an atom is neutral and it has 14 protons, then it must have 14 blank. So positrons is not a thing that we've talked about. I don't know what that is. Neutral means that all the pluses have to balance out with all of the minuses. So protons are plus things, which means that we need to have 14 of the minus things. Neutrons are neutral, so that can't be it. And energy levels is not something that relates to whether something is neutral or not. The correct answer is electrons. Number 9, given that an atom is neutral, has a total of 21 subatomic particles. And we're going to pause right there. Subatomic particles means protons, neutrons, and electrons. So we're talking about 21 of these three things in some combination. And it says in the nucleus. So right off the bat, we can eliminate electrons. We're talking 21 protons and neutrons together. And then it tells us that there are 13 neutrons. So what that means, even before I finish reading the rest of the question, I know that 21 minus 13 is going to tell me the amount of protons. So that means that 21 minus 13, that means that we are going to have, let me get my pen back, that means that we are going to have 8 protons. So we'll keep reading the question just to make sure that we're answering everything correctly. It says, how many total protons and electrons does it have together? So it told us in the very beginning of the question that it's neutral. I just figured out that it has 8 protons. So how many protons and electrons together? Well, if it has 8 protons and it's neutral, it's got to have 8 electrons also, which means that protons and electrons together have to be 16. Number 10, who am I? I have an atomic number greater than chlorine, but less than bromine. I have 2 valence electrons. Okay, so this one I'm going to use my periodic table. So I'm going to scoot down just a little bit, and it said to look for things with 2 valence electrons. And the periodic table is really well organized because if I look right here in the second column, this is everything that has 2 valence electrons. So it said in the question that it's got to be bigger than chlorine, which is right here, yet smaller than bromine, it said, so that's right there. So we're talking anything from argon through anything in this region, and we know that it has to be in the second column, so automatically I know we are talking calcium. So scroll back up, make sure that's one of my choices, and it is. That's letter C, so calcium is my answer. The next one says, number 11, blank is a noble gas, which means the far right column, that does not have 8 valence electrons. So I'm going to again go down to my periodic table, and we're talking everything in this last column here, which has all the valence electrons equaling 8. And it says that it does not have 8 valence electrons. So everything in this column is noble gases, and helium is the only weird one in this because if you remember, helium only has 2 protons, which means that when it's neutral, it has 2 electrons. So if I'm going to make a quick Bohr diagram, there's my nucleus. I don't know why it keeps doing that. My nucleus there in the center. And the very first, well, it only has 2 electrons, and the very first ring can only hold 2. So there's my Bohr diagram right there. And it has a full outer ring, which is why it's in this 8th column, but it's the only one. So if you go to neon as another example, neon with its nucleus there in the center, it has 10 total electrons since it's number 10 on the periodic table. So it's going to have 2 in the first shell, and then 8 in the next shell after that. So we draw a Bohr diagram, it looks like this, and everything under it is also going to have 8, or at least a full outer shell. So scrolling back up to my question, it said number 11 is a noble gas far column. Helium is my choice. Helium's my guy because it has 2 valence electrons in the outer shell, and it's still in the 8th column. For number 12, it says nitrogen 14, which means that it has 14 protons and neutrons, and nitrogen 15, so they're both nitrogen, are isotopes of the element nitrogen. Describe how these isotopes differ from each other. How are they the same? Use at least 2 complete sentences. So I'm going to make a sentence for how they're the same, and then I'm going to make a sentence for how they're different. So for how they're the same, let's see, get my cursor here. For how they're the same, they each have the same amount of protons. That's why, if I can get myself back, they are both nitrogen. For different, because they're both isotopes of each other, that means that they have different amounts of neutrons. So if you want to get really specific, nitrogen 14 has 7 protons and 7 neutrons, whereas nitrogen 15, because of that bigger number, has 8 neutrons. So it's the difference in their neutrons that tells them apart. For the last one for this video, number 13, explain how the following terms are related: atomic number, isotope, and mass number. Be sure to use all 3 words in their definition in your explanation. The way that I'm going to answer this is I'm going to speak to a particular element, and you can pick anything, or you can do this another way too, but the way I'm going to do it is I'm going to talk about carbon. So I know that there are different isotopes of carbon, and I'm going to start out by saying all isotopes of carbon have the same atomic number, and that means protons. However, all isotopes of carbon have differing numbers of neutrons, which gives them an average mass. So remember, the average mass is because all the isotopes have different masses. We average them together. That we call the atomic mass. So I've already used isotopes, I've used atomic number, I've now got to use mass number. So I'm going to say a mass number tells the chemist how many protons plus neutrons are in a certain isotope. So I could take, for example, I'll get my pen back. I could take, for example, any old isotope of carbon, and I want to say maybe carbon 14. So carbon 14, when we say carbon 14, this is the mass number right there. Or if I were to then say like carbon 12, they're both still carbon, but now that's the mass number. It represents the protons plus the neutrons.